To talk about gifted students, we have Jerry, who has worked for more than 20 years with gifted math students. I have personally sat in his classes that he has done at Manipal, have been in some of those and seen him interact with students. He's written many books as well. A big welcome to Mike. Mike Purcell was the head of school at the KC High in Chennai and has been a maths teacher to students for more than 25 years. He has taken a special interest in nurturing gifted students, and we'll hear from him. Sridhar Rajgopalan is the co-founder, board member, and the chief learning officer of educational initiatives. So welcome, Jerry, Mick, and Sridhar. Welcome, and thank you for spending your time with us. So Sridhar, starting with you, you have spent 20 years on identifying students through student assessments. Could you share a little bit more on how can we identify gifted students?
Yes. So yeah, good evening, everyone. A pleasure to be here in this conversation. And giftedness, identifying talent is something that both as parents, it's something that we are always very keen on doing. But I also often say that there's a social purpose in this, because if you can identify students who have any special abilities like this, there are a number of significant social returns that can come from this. Now, obviously, we must understand that giftedness can be of many, many dimensions. They could be, you can obviously be gifted academically, but it could be in music, or it could be in a talent that is not even particularly identified, a skill that I kind of systematically measure for, or that students are doing regularly. And hence, in the kind of assessments that we do to identify gifted, the logic that we use, and this is also done in many of the programs in the US, for example, when I try to identify giftedness in a certain way in a large population, which is to say, what is the thing that students are regularly doing? So if you have students in a school system and they are learning language and maths and science, so on. One way of looking at gifted is that when you have a large group of students doing a particular content or curriculum, can I identify the students who are able to perform at a significantly higher level than other students on that same content? Now, naturally, by this definition, I am not identifying students who are, say, gifted in music, because every child is not learning music, which does not mean that I do not have children who are gifted in music. It just means that they might be falling outside this method that we are using to identify talent. So what we do in this method is that we take these core subjects that anyway students are doing and that you are testing for. So you might be aware that the asset test is something that we have right from grades 3 to 10 in India, and it covers the school subjects. It covers 5 subjects. The other point I just want to mention here is the age. So if you catch children too young or too old, there could be challenges in identifying giftedness. So below a certain age, children are still developing and learning the basics of the various concepts. Again, you will have exceptions, you will have precocious children. But typically what we do is around the grade 5 to 8 range, which means when children are, say, 10 to the next 4 years, 10 to 14, 10 to 15. At that time, if we have these assessments which show who are the students who are performing in the top 1% or the top 2%, and we often do this in 2 stages. So you identify the top 10 in the first stage, and then you have some of them come back, those who are in the top 10, and they kind of take another assessment, which we call the higher level assessment. In the second assessment, you actually assess them 1 or 2 grade levels above their grade. That means a grade 6 child will take a grade 8 test, a grade 7 child would take a grade 9 test. And then those who perform in the top 10% of that test, and these numbers can vary a bit, those are the ones that you identify as being in that pool that gets an opportunity to go through these programs. And this is common to, this is a method that's also used in some of the programs in other parts of the world. So that is one way to look at giftedness, where you look at students in the course that they do, those who are kind of showing higher ability on those particular parameters, often assessed in a two-stage manner like this. So that is one way that we have found to be quite useful and reliable.
Thank you, Sridhar. Mick, we learned about the age that Sridhar talked about. So at what age does giftedness become visible, and how can teachers or parents identify giftedness among students?
So I think Sridhar makes a good point about too young or too old. I would say in the primary years is when it becomes pretty clear. And in terms of mathematics, let's just stay focused on mathematics for this conversation. Obviously, music, literature, etc. There are many different ranges of giftedness. But in terms of mathematics, one of the things that we see, as Sridhar has already pointed out, is that there may be one or more kid in the class who is significantly above the rest of the class. And in particular, I would say several grade levels ahead of the other kids in the class when it comes to doing mathematics. But that's just one indicator. There are a lot of other important indicators as well. And some of these indicators you can find tests online, screening, they call them gifted screening tests for parents, where you can look at things like the child's attitude, the curiosity, how quickly they solve problems, how they approach problems, etc. And I think it's pretty clear to most teachers and even to some parents, although I think parents need to question their own motives when they're actually thinking about whether their child is gifted. I think it's pretty clear to teachers when a child in a primary school, particularly around something like third, fourth, or fifth grade, is just several levels above the other kids in the class. And that's when you would hope that that teacher in her or his professional responsibility tries to do something for this child, because the child is clearly not being challenged in the class. So that's when the teacher would hopefully talk to the administration of the school, and then you would set up some kind of screening or some kind of assessment and see what can be done for this particular child.
I might like to jump in on that for just a second, if I may as well. I liked your idea, Mick, that sometimes you're not just focusing on a single obvious measure of this type of giftedness. One of the things that really seems to jump out to me, at least in the classroom, is this a certain level of intensity. Gifted students often tend to be very intense, very sort of sensitive to their environment. It doesn't always show up academically. In fact, sometimes there can even be academic issues where they're not performing as well as you might expect, but they just, it ties in a little bit with what Nick was saying about this level of curiosity. It's just they have to know, they have this intense desire to learn and understand the world around them. And that's something we can definitely make use of and tie into in the classroom.
Jerry, thanks for adding on that. Now, you have actually run courses for both the EI Asset Summer Program and GenWise. Could you share a little bit of what approaches you take? And is your approach different, let's say, for gifted versus non-gifted students?
Sure, and yes, and thanks for having me as part of this panel. I'm very happy to be here. Probably as I think back when I was visiting India and teaching these courses, one of the biggest things I think that stuck out for students, not even something I necessarily intentionally built into the course, but was part of it, was this idea of allowing them to be, and even expecting them to be a little more independent in their thinking. A lot of these very bright students have learned to follow the rules and to to give the answers that the teachers expect. And to focus on quick computation and things like that, but it can still be challenging for them to think their way through complex problems in their own ways. So providing the kids with really rich, deep, complex problems that can be solved in a lot of different ways, and then having them collaborate with each other and share ideas and compare their approaches, and sort of learning to think, to realize that there are a lot of different ways that you can approach a single problem. And it's really nice in that respect to begin with problems that are open-ended. People talk sometimes about what they call low floor, high ceiling tasks, with the low floor meaning that students can enter the problems on many different levels. But if you're sort of more naturally advanced in your thinking, you'll enter the problem at a higher level and kind of move up in it from there. And then the problem can be extended in a lot of ways where you can ask deeper and deeper questions and go further and further with it. So this is a pretty powerful kind of a tool for working with these kids. In my classrooms, sometimes the problems would be quite honestly so open-ended that students would be asking me, well, what do you want me to do? And part of my answer to that question is I want you to figure out what you want to do or what you need to do. And that can be a little disorienting for them, actually, but that's in some ways the type of thing that they really benefit from, is to sort of learn to think for themselves and to ask their own questions. So problems that are open-ended, that have lots of strategies. Another thing, like in the classes in India that I taught, is that we wouldn't all necessarily be working together in lockstep, doing the same things all at the same time. So different students or groups of students, we would generally be working on the same set of ideas and problems, but people might be taking off in their own directions and then kind of sharing out with each other. So those are probably, I think, some of the main differences. Relative to non-gifted kids, I mean, honestly, a lot of these strategies that work really well with gifted students and have even been designed for gifted students work, quite honestly, equally well with all students. I think the main differences that I would note is, like with gifted students, first of all, you do tend to do things more quickly. You do things in a more abstract way. You might choose topics that are beyond the curriculum sometimes if the curriculum has already been mastered. So there are lots of fun and interesting math topics that are related to, but not usually taught within the curriculum. And then we have an opportunity to go deeper into the concepts because the kids will kind of naturally go in that direction.
Thank you, Jerry. Mick, you've actually led many schools, right? What Jerry describes seems to be extremely difficult in terms of always thinking about low floor, high ceiling, being able to offer that range of difficulty levels to students. So what is the role of schools? How can schools be equipped about identification and then nurturing of these children? And what is the role of the teachers in these schools?
Well, this is a pretty tough question, and I have a lot to say. And I do want to add a little bit to what Jerry said as well. Usually when you're talking about, and this is for schools, for teachers, for parents, for gifted educators, for everybody. Usually when you're talking about what to do with gifted children, the first question that comes up, the main debate, the first question that gets answered is acceleration or enrichment. Now, I don't think it has to be either one or the other. I think both are a good idea, actually, but I'm also a big fan of acceleration. And, what I've seen, and I also have a lot of experience directly working in a gifted program and with gifted kids in mathematics. And what I've seen is those kids themselves really appreciate acceleration. So, I had a kid who was very gifted in mathematics when I was a sixth grade mathematics teacher. And it was a really curious thing that happened. First of all, I knew that he was gifted in mathematics before I even met him because all of his classmates told me, "Oh, you're going to have him in your class. He's a genius." That's what they said, right? Then he came into my classroom, and almost immediately I could see this kid was several grade levels ahead of everybody else. And what he was doing was really curious. He was in sixth grade, but he was doing binomial theorem and partial fractions and all this 11th grade mathematics. And he was sneaking these little Kumon sheets into his math class so that he could practice binomial theorem when he's in the sixth grade, right? And I could see that this kid really loved accelerating up the curriculum. So one of the things that I would say about, Jerry's comment, if the curriculum has already been mastered, giving the kids enrichment activities, for kids in schools, the curriculum has never really been mastered because we can always actually accelerate the kids if the teachers and the administration are willing to do what's best for the kid. And that's where you have a lot of problems in schools. So when you look, for example, at famous mathematicians like Terence Tao or Akshay Venkatesh, they were accelerated through the curriculum when they were in high school because their parents took them out of school to bring them to the local community college so their mathematical talent could be developed. So I think one of the things that we have to do as teachers in schools is not to get in the way of kids who are gifted in mathematics and remove any obstacles that the timetable, the constraints, the systems that we've used, the legacy systems are placing in the way of these kids. Remove those obstacles and let them develop their talent.
Noted. Sridhar, Mick almost suggests that to do this, we might need a different school for gifted students. So, what does research say? Like, should we have a school that caters only to gifted students, or should it be another form of intervention?
Yeah. So yeah, this is a tough question, but and there are examples. I mean, you had situations in Russia, which was, I think, the most systematic attempt where they would kind of have schools that were specifically targeted and focused on identifying and training gifted children. What is found is that you do want to have a kind of socialization. So you have children whose ability, remember that here we are focusing on gifted in mathematics, but then when a child is learning, especially in primary and middle school, they are doing a number of subjects. As children, these students have, there is socialization, they are interacting with children of their age group, and they might be ahead in maths, but not necessarily in all the other aspects. So what we have found is that it is very useful, it's very important to, we talked of acceleration and enrichment. It's very important to give these children access to something that, does a few things. One, allows them to interact with other students who are similarly inclined, right? So if I'm in a grade, in a classroom where, for all you know, I could be being made fun of because I like doing maths, versus in a group where everybody else is also passionate about this and finds this fascinating, maybe in a slightly different way, maybe obviously there are some dynamics there, but at least, there's something there that I kind of connect with in students. So you also need some, and then there's the actual part of acceleration, enrichment, adults or somebody who's kind of saying, okay, have you looked at this? Or, here's a tough problem that you might want to look at. So it's like, you want to provide exposure to that. You definitely want them to get this and experience it, maybe get a chance to build these relationships that may continue even beyond this particular interaction or the few weeks that it happens. But you may not necessarily want to have them in that classroom entirely, which is what happens when I have a kind of school for gifted, and like I said, because it may be different for the different subjects. So the one model that seems to work well is this one where you give these children an opportunity to spend a certain amount of time together. We have found that programs that focus on a summer program, so 2 weeks, 3 weeks, 4 weeks, often in these programs you can actually come back, so you can, you don't have to qualify each year. So once you are there, you could do this 1 year later, look at maybe a different topic. We also find that in many typical summer workshops, not for gifted children, you may have 5 courses running, and each student does a bit of each of the 5 courses, which kind of goes against the ability to go deep, to take a problem and to go deep into it. So we find that, have a 2-3 week or 4 week process where you're kind of going deeper into a particular thing. So not a school for gifted where you're permanently kind of keeping them in a different group, but where they have an opportunity to socialize in a regular way in the school, but also have this opportunity to interact with other similarly interested students and adults who are kind of going to develop that interest further. Seems to be a good model that works and kind of gets the best of both worlds, is what we feel.
Thanks. Today in the audience, we have lots of parents as well. And parents are always curious and eager that for their children, what enabling conditions can they create so that their students can excel in all subjects, but specifically, let's say, mathematics and science. So there's a question for each of the three of you. Let's go with Sridhar, Jerry, and Mick in that order.
So the question is that what can parents do? Is that the question?
Yes.
No, so I think that the first step, is to kind of keep an eye and identify what is it that your child is like interested, talented. So I would say understand the child in terms of his or her interests, in terms of where the child is showing this kind of special interest or talent. And it's the balance between encouraging the child, helping them to kind of move ahead, as opposed to pushing them. And specifically in India, I think this challenge that you have the school system, you have the marks, which are likely to be very, very narrowly focused, saying do this well, and often a thing that if you do something beyond this, how is it going to help? So kind of balancing out that piece and encouraging the child to pursue the area of interest, good books, materials that they can access, but books for specifically I would mention, but other kinds of activities that are there. And then again, we don't have too many opportunities in India, but ways of getting the child assessed, so you actually kind of get to know in a more objective way where the child stands. So maybe I'll throw these out and then go further as we get more ideas and discussions.
I'm going to throw in a shameless plug here that for assessments of giftedness, EI runs the EI Asset Talent Search, through which we do a 2-layered stratification process. But yes, Jerry, would love to hear from you on, what can a parent do for their children who might be gifted in maths and science, and what should they create in terms of enabling conditions? Yeah.
Well, I'd probably follow up by just saying that I would have led with a lot of what Sridhar was saying. I think the idea of just kind of watching your child and rather than looking for ways to necessarily, just look for their interests and what they seem to be really focused and curious about, and just give them as many opportunities as you can to follow up on the things that they're passionate about. And obviously that applies to anything. It applies very strongly to mathematics. And then I honestly don't think in some ways that you need to do too much yourself in terms of like teaching them or trying to force them along faster or anything like that. And if they're really curious and they're interested and they're able to do it, then most likely they will do it. So you don't need to be teaching them a lot of things. You don't need to be trying to give them extra math work to do at home that they wouldn't necessarily choose to do. And you don't necessarily need to worry about them like learning how to do long division earlier than other students or anything like that. Just providing them the things that they're really interested in. And then I do have a set of like resources or whatever that I'd be happy to share at some point in whatever way that would be most convenient to do that. But when they do have these really challenging and interesting problems to work on, I think one of the hardest things to do is to actually step back a little bit and let them do the thinking, rather than if you're interested in it yourself as a parent, you want to step in and do everything you can. Let them do a lot of the thinking, and then your role becomes one of just, hopefully, if the problems are truly challenging, they're going to get frustrated sometimes, and gifted students often don't have practice learning how to manage that frustration. Helping them learn how to manage the frustration, to take a break, to realize that they don't have to be perfect, to ask for help when they need it. And then they're going to need sometimes, just because they're really bright in math doesn't mean they're very good at managing their time or their study skills. So that's a huge role for them. And then another thing, and this is really hard for some of the brightest students, it's still important for them to be able to verbalize and write about their ideas in a clear, meaningful way. And it's not just so that they can tell the teacher like the show your work kind of a thing. It's not only so you can tell the teacher what you've done, or so that they can make sure that you've done, they've done the steps properly. Communication is, yes, it's partly sharing your ideas with each other, with another person, but it's part of your thinking process. So as you learn to write things down in a clear, meaningful way, to explore your ideas and to communicate things with precision, to get a lot of data on paper and to just write your ideas down, that actually helps you develop your thinking skills. So it's partly communication with others, but in a sense, it's also you communicating with yourself. And simply reading what your children write sometimes and say, I don't understand that. Could you explain it in a different way? Or helping them like communicate their ideas and talk about them with you or whatever. Those are big things that I think parents can help with.
Thank you, Jerry. Mick, what advice would you give to the parents who are here in terms of what they can do to support their children?
Yeah, I think Jerry and Sridhar have identified a lot of good things. I think the environment is really important, and creating a supportive environment, as they've mentioned, surrounding them with math books, developing their curiosity about mathematics, giving them exposure to websites like Khan Academy and Wolfram Alpha, etc., getting them interested in using computers to do mathematics. I talk to students about this all the time, that mathematicians use computers. We all realize that computers are very useful in mathematics. Surrounding them with mathematical puzzles and Rubik's cubes and manipulatives and things like that is always a good idea. But I also really like Sridhar's point that they need access to other people, teachers and students, who are talented in mathematics, and they need to connect to those communities. So for example, when I've seen kids who are speed cubers that do the Rubik's Cube really quickly, and they tend to be very good in mathematics, they connect to other speed cubers and they form these little online communities of highly intense, motivated, talented young mathematicians and puzzle solvers. And when you connect to those kind of communities, that really inspires the kids and really motivates them and pushes them, and that's really important. I think when I talked about those two Australian mathematicians earlier, that's one of the things that their parents did for them, is they connected them to communities of similar thinkers, kids who could think at high levels about mathematics, right? So I do think that these summer programs are an excellent idea. I have had a lot of students go to one called Canada USA Math Camp, and they come back the next year just super motivated because they spent the summer connected to other highly gifted mathematics kids, and it really stimulated them a lot. So I think it's really important for parents to try to both create the right kind of environment at home, but also help the kids connect to other environments where they will be around other gifted kids.
Noted. Thank you, Mick. I would like to now get some audience participation. So may I request Lakshmi and her husband Vadivel to unmute and ask a question, please.
Am I audible now?
Yes, you are.
Okay. Thanks for the opportunity, Pranav and Vishnu sir. So the question what we have is, we have a kid, okay, who is quite advanced. When I say quite advanced in mathematics, probably 5 or 6 levels grades above, okay. But when we were actually looking for resources and then how do we handle it, one school of thought or the advice what we received is not to accelerate too much because it will create a burnout very quickly. So to pace it out and then try to get him more in terms of the social connect aspects and other things are more important, and not to accelerate too much. So what we are doing now is we have put him in an alternate school purely from a social connect perspective, but we are also getting some mentors for keeping his interest alive. So is that the right way, or is there a better way to handle this?
But even one quick clarification. Are you also doing something about acceleration or the math content apart from the alternative school for the social aspect?
Yeah, we do have mentors who have doctorates in mathematics from NAAS to keep his interest alive, which is also going on. But so earlier the comment what was made was it's better to take from the regular stream and then put him in an accelerated course, right? That's where we were thinking, what is the best way of handling this? That's the question what we wanted to ask in this forum.
Okay, thanks for the clarification.
Would anyone like to take that? Tough question.
Yeah.
Okay.
Can I ask, what does he want to do? First of all, I think it's always a great place to just try to understand the child, because every child is different, right?
Mm-hmm.
And what is he enjoying? What does he like the most? Which classes is he most excited about? Which teachers is he most excited about? Which topics is he most excited about? And have you had that conversation with him? And are you paying attention to that? As Jerry said, paying a lot of attention to the child is really important here.
Yeah, we do that, and he really wants. He's very interested in advanced. Basically in mathematics as well as physics, astronomy, and other things. And we are channelizing through external support for each of these things. Okay, but when it comes to regular, going to a formal education system, right? There he wants to be spending more time to play with the kids of his age. So that is where there is a mismatch between the real capability versus what do we really want to do, right? So how do we balance that, or how do we handle that is the question.
So I hope I'm understanding your situation correctly here. So you said your son is about 6 levels ahead, is that right?
Yeah.
Okay.
5 to 6 levels, yes.
Right. And if you're noticing that they really want that social interaction, then that's obviously going to be a really important thing. It certainly can be the acceleration piece. This is really an interesting thing. This will probably be a little bit of a counterpoint to some of what Mick said before. It's it's so important that if the students are accelerating, that they're doing it sort of for their own reasons, and it's kind of a natural process for them. I think there are a lot of resources out there that'll allow you to go deeper into the mathematics that he already knows, rather than kind of pushing on to the next level. There's a certain limit to how far you can go with that. And again, I'll mention a couple things here right now. Like if you want, like he can be exploring more deeply rather than pushing ahead to the next level through, there's a website called Brilliant. I think it's, I can't remember if it's .com or .org.
It's .org.
Yeah. Yep. Cut the Knot. There's Enriched Maths. 3 Blue, 1 Brown Mathologer. I know I'm saying those really quickly, but I can definitely make those available to people. Math Pickle is a really great website. So there are a lot of opportunities for kids to go into these things more deeply. And for most kids, I would say that type of approach is going to help them learn the mathematics better, and is probably going to be at least as interesting to them. Checking that out and using it as a way to sort of expand and deepen their mathematics, as opposed to necessarily continuing to push faster and faster, is often effective for most kids. When you get to a certain level, like you're at the top 1 to 1, 1/2 to 1%, then you really have no option but to accelerate, because they just will. They'll learn it that fast, and you can see that it's happening. So kind of balancing that against, is it the kid who's actually sort of naturally accelerating themselves, and you're just simply putting them in a place that helps them do what they're naturally doing anyway? Or are you kind of, you know, saying, well, okay, this is the next step, you have to do this. It sounds to me, though I can't tell for sure, that probably your son could benefit from that kind of, you know, like really reaching out and deepening and that type of a thing. Though it's really hard to know without actually knowing them. So
thanks a lot. It's really helpful.
Yeah, if I would just kind of add, I think you're already doing some of these things, but you know, I would just see these 3 or 4 aspects, which is mentors. I think you mentioned that. I think that is the very, very powerful thing. The second is that trying to identify a community of peers, not easy, obviously, but students who are similarly kind of interested in those topics. The third is resources, whether it's books or materials that we talked about. And the fourth is exposure to something that is of his interest, you know, which may be non-math, which may be like maybe just being met by the regular school. But I would say it's basically these 4. I think you're already doing some of it, but I think it's just doing more on this, aligning with the child's interest.
So I want to sort of, you know, so far we've talked age agnostic, right? If we could sort of take 3 different age profiles, let's say a student that's 6 years old, 10 years old, and 14 years old, right? What would be different in terms of as it relates to giftedness in math? So if you could maybe take 3 students that you know of and share about them, what you did with them, what are some resources that are relevant for them, that would be super helpful.
yeah, I think for the very young students, it's definitely harder to tell. What tends to happen with the very younger students is they will show a lot of sort of computational precocity at an early age. And it's very hard to tell from that whether, you know, that's an indication of giftedness or not. So I think more and more the trend is to be especially careful not to focus too much on acceleration driven by anything outside the child's own kind of natural, whatever direction they go. In the earlier ages, finding ways like the Art of Problem Solving is an organization which has some really good materials out there, and they are somewhat accelerated, but their materials are written in a way, first of all, for the very young kids. They have something called Beast Academy, which it's really written, you know, to kind of, it's fun for young kids and things, but it's very, very deep mathematics. And it's a regular curriculum that you can follow through. So, and looking for, you know, this Math Pickle website has stuff for, like, you know, very young kids, like 3, 4, 5, 6 years old, that they're the kinds of problems where you can work on these things as a 4-year-old, and you can also work on them as an adult. And they can be handled on so many different levels. And so I think those kinds of opportunities for the really young kids are probably the most important. Probably, you know, trying to say, okay, well, you, again, that you want to be able to do this, this, and this, you know, 4 or 5 years faster than your kids, than your peers or something like that. If that's adult driven at all, that really does tend to backfire when they get a little bit older, because all of a sudden the students are accustomed to thinking of themselves as being so advanced. But when they start dealing with more conceptual based learning as opposed to like the concepts, it can be very frustrating for them, and they found that their knowledge level can be a little bit more superficial and that type of thing. So more cautious about acceleration, I think, and more about depth in the earlier ages. As both Sridhar and Mick have mentioned over and over, like lots of opportunities to work with other kids who are kind of thinking in similar ways that they are. As you get older and you approach sort of the, I don't know, sort of the, I might use a slightly different age range, if that's okay, than what you had mentioned, Pranav. But as you begin approaching sort of 4th, 5th, 6th grade level, you start, I think it starts becoming a little bit more clear. And there are just, again, there are lots of resources out there. There's so many opportunities to give kids ways to look more deeply into things. The number of math topics, again, something I'm happy to share at some point if you like, where they can really dig deeply into things is profound. When you get to middle school, there is kind of a nice little indicator. And you may need to reach out to others if you're not sure how to recognize this yourself. But if students are sort of naturally doing proportional reasoning by, you know, 3rd, 4th, 5th grade or something like that before they've ever been taught, and that's going to be ratios, proportions, percentages. If they just know how to solve these problems with knowing no one ever has taught them, that's a pretty good indicator that there's, if not giftedness, at least some kind of precocity there that you really need to watch for. And then as you get older and older and move on to the high school grades, then it becomes clearer whether actually accelerating the kids really makes a lot of sense. And I'm honestly not too familiar with the structure of the high schools in India. I know in the US, at around that point, tracking where students actually just sign up for different courses, depending on, you know, their ability and how quickly they're able to move, becomes fairly common.
Okay, I'm gonna actually, there's a fan club here for you, Jerry. We have Siley, who had an experience with her son. Siley, would you like to share a little bit about that?
Yeah, so Rehan, my son, he's 12 now. Lockdown and school closures were a boon for us. He was never enjoying school as such. Acceleration, schools in India are not very much for it. And also, the school told us that he's so ahead of his age, and it doesn't make sense to accelerate 2 or 3 years because of social development, which we also agreed with. When I saw a course on GenWise, I reached out to Vishnu and I asked him if he could also join. He was pretty young for that course because I think he was in 6th grade then, in between 5th and 6th, and this course was for 8th grade onwards. But Jerry was kind enough to let him in. Initially, he also had some issues with communication where not being used to work in groups with older kids, he would try to dominate the space but Jerry explained to him what was expected. He really tried to understand him. And since then, it has been a beautiful journey. He's done a few courses, long ones with Jerry, and Jerry is his favorite teacher. So helped a lot, and he's an independent thinker. That's what Jerry encourages. So I would say it's very important to find the right mentor and for the parents to take back seat so that we don't have to do anything.
Thank you, Sally, for sharing your story. Nishal, you've had your hand up for quite some time. Could you very succinctly, perhaps in 1 minute or less, ask your question?
Yeah, sure. Thank you so much. This is Nischal, and glad that you provided the opportunity. So basically, I just wanted to share my experience. In the early years, I might not have considered myself as a good math student, but when I actually went into college and the kind of teacher I had, it developed my interest in mathematics, and therefore, and also the other kids that I used to sit with who were brilliant in maths or bright in maths, and I developed that interest in acumen then. And from there onwards, I really like mathematics, and I've developed, that interest. So my idea, I'm not too sure, but my opinion on gifted students, I wanted to understand what's the difference, because let's say, for example, in my case, I was not even aware that such kind of mathematics calculation is done in such a way. So the method of how the thing gets calculated in a different way are taught by different teachers. So what I want to express here is that how do we, like we said, that we should give access to children to different forums, but it is very difficult in India specifically because I'm not too sure how limited forums are. How do we identify? Identification is the most important thing here. How do we identify, like children like me who didn't know that such kind of easier calculation methods are there, and how to, so that's my question basically, that how do we identify really? Many kids are maybe left out because of that, because they think they are not good in maths, but actually what happens is that the way they are taught, they are not able to comprehend it till the time there is some teacher whom they really understand everything that is being taught in the class. So
Noted. Thanks for asking your question, Nishal. Perhaps Sridhar and then Mick, would you like, the two of you, like to answer this? Yeah.
Yeah. No, so I think absolutely, Nishil. I mean, definitely you will have cases of students who are late bloomers. I think we all know so many examples, and in many cases, it is a teacher who inspires, and and there are examples. I mean, you had great scientists who were considered like slow when they were in school. So, and so that is where I think this entire process of, say, identifying and doing specific things, it has its limitations. There are students who kind of pick up, develop an interest, and you can never say when that will happen. It could be grade 8, but it could also be in the first years of college. So I don't think that anything that one is doing here is in that sense to try and exclude. And I think Jerry, as well as Nick, made this point that many of the techniques that one talks about actually work very, very well with every child when you kind of focus on their interest and encourage them to develop it. And many people have also found that a lot of this kindling happens because of the teacher and the mentor. We have found when we work with children that one of the strongest motivations to learn, even for very small children, is that an adult who cares for my development, not for my maths, but for my development and for me. And I think the same thing happens. Like I have this teacher in grade 8 who is like really, connects. I connect with the teacher connects, and then I develop a passion for that subject. So in no way is this the focus on giftedness, these assessments kind of meant to exclude, and many of these principles would apply to all children. Having said that, you do have these children who kind of show extraordinary ability measured in these very objective ways. And it's also true, I mean, there are these longitudinal studies that have traced these students over 30, 35, 40 years now. And all things happen. I mean, there are students who show exceptional ability, and they're kind of doing some work, but it does not, you might say that, okay, did they kind of meet that completely? And there are others who do, they become CEOs of Google and things like that. So all of these things do happen. But I think these principles are that you try and identify it, you give them that kind of support, and that's why I think the role of the human support, if I may say so, along with the resources, can be really critical. The other point I want to mention is it's absolutely true that both resources and awareness is limited in India. When we look at some other countries, the US in particular, but in some other countries, the availability of these resources, people have kind of gone into the area and gone in depth, and maybe people in this forum, we need to do something to kind of to develop that for other parents. But it's absolutely no doubt that, and the internet is an advantage because one can access that, but both because of the rigidity of the school system as well as the fact that organizations haven't gone deep into this, there is an opportunity. I see it as a positive opportunity for all of us to do something in that area.
That's right. And I have also another question.
Sorry, Nishal, I'm gonna make sure there are a couple of people who have raised their hand. I'm gonna give Mick an opportunity to perhaps add, and then go to Jyoti after that.
Okay, sure.
Yeah.
I think I agree with what Sridhar said. Yeah, it's not so much about identifying the child as it is about putting the child into the right environment where he or she has good instruction, good teachers, lots of resources, lots of opportunity to blossom, as you did when you went to college. So I think the best thing you can do, quite frankly, is choose a good school for your child and make sure that your child is in a school that has good teachers. And that unfortunately is a lot more difficult than it should be.
Mick, you've led schools before, and are there particular boards, let's say between the CBSE, ICSE, IB, the Cambridge board? What do you think is the role of board, and in terms of the school's ability to deliver high quality?
I honestly don't think the board matters. I really don't. It's mathematics either way. And I think the school matters. And whether you have the right teachers and the right attitude in the administration, and that the school is doing what's best for all the children, and whether the school creates the kind of nurturing environments where, as Jerry has said, you can have these low floor, high ceiling problems, where you can have a lot of curiosity, where you get access to resources. And I don't think that we are actually, in this day and age, limited here in India about our resources, because the internet, as many of us have already described, is just an infinite pool of wonderful resources for children who are mathematically curious. And when it comes to the young ages, I cannot emphasize enough, first of all the websites that Jerry has mentioned, but the artofproblemsolving.com and Beast Academy, those comic books or graphic novels about mathematics, are absolutely brilliant. So I would recommend that the parents get those and read them, and that the school is open to using these kind of resources instead of just being infatuated with trying to deliver the curriculum. So that's what we're really looking for, more than which board, is how is the school handling its board, and is the school open to creative solutions for kids who have mathematical talent.
Thank you, Mick. Jyoti, you've been patiently waiting. What's your question?
Yeah, I would like to ask that we as a parent, what can we do to develop an interest in mathematics in our child?
So if you're beginning, perhaps I'm assuming that your child is not necessarily interested in it naturally right away or whatever. I think everything that everyone has said up to this point probably applies in the same way that it would with gifted students or otherwise. Just creating a rich environment where you show your own interest in mathematics, you show that you're curious about it, that you believe in your ability to do it, and then just provide things that are kind of fun mathematically related based on your child's age or whatever.
My child is 11 years old.
Okay.
She's in sixth grade. Yeah.
Yes. And so, I mean, the kinds, just open-ended kinds of fun problem solvings and puzzles are probably the best. Like if they're already showing that interest, then, you know, just providing things that feed that interest is one thing. And if they're not, I mean, honestly, just having these things available and just sort of modeling that yourself, I think is a really huge thing. So your Rubik's Cube, there are Ken puzzles, there are lots of things that are just kind of naturally fun for kids. And then just kind of, there's a piece of it which I think is quite honestly acceptance. Kids are different. Kids like different things. They may or may not develop the interest in the way that we as parents would ideally hope for. And just to sort of say, okay, that may not be what they want, or it may not be what they want right now. Just more providing an opportunity and modeling your own interest, I think, to me makes the most sense.
Okay, thank you.
Yes.
Can I add one thing? When I talk to parents about this particular question, when we're talking about kids who are gifted in mathematics, usually there's a genetic component, and there's going to be at least one parent who's really interested in mathematics. And when you're working with your kid in mathematics, I always feel, and I think Sridhar and Jerry will confirm this, that laughter, fun, joy, these are really important components, and they're very common to all mathematicians. One of the things that I do is I actually show videos of real mathematicians doing work, and that's almost always accompanied by mathematicians laughing at themselves because the problems they're trying to figure out are so difficult and so puzzling. And I know Jerry wanted to talk a little bit about the attitude of mathematicians. It's really important that you approach these problems with a joyful, fun-loving attitude that we're going to solve this puzzle, even though it might be more difficult than we can comprehend. At least we're going to give it a try.
Yeah, that's really nice. Thanks for sharing.
All right, talking about fun, loving things, I'm actually gonna call upon Vishnu Agnihotri, who's the co-founder of GenWise, to perhaps tell us a little bit about what support systems are available for children that are gifted in math, especially in India.
Yeah, I noticed that a bunch of parents have asked this question. So I'm just going to name a few resources and organizations which support kids who are, say, gifted in math. But I will also suggest, so I will share a Telegram channel which we have, the Gifted India Network. And often parents are able to make better suggestions than us because they've taken a lot of effort to find someone, in their city or in their vicinity. And often this information is not easily available. So apart from some of the names I mentioned, feel free to join this group. I will share the link towards the end of this talk. So there are, so unfortunately, it's not very systematic. There are, the GenWise, of course, conducts advanced math courses with the help of people like Jerry Burkhardt, Utpal Chattopadhyay, and a bunch of other people. So we have online courses, we have in-person programs, and so on. Sometimes when we are not able to address a child in a large course, we just connect them directly to the mentor. For example, if a child is like Rehan's mother spoke, the child is, like 3-4 levels above. And there is, we can't always put him in a group. So he goes directly to a mentor. So that is one. There is a very good organization called Raising a Mathematician Foundation. Vinay Nair in Mumbai runs that. They have some relationship with Art of Problem Solving and Brilliant also. They have Ken Ono, who runs the Spirit of Ramanujam fellowship out there. So they are doing great work. In fact, they have a completely free 1 week online course only for girl students, because sometimes, because of the social sort of conditioning, girls don't take up math. So there are different things. There are Bhaskaracharya math. There are so I can share this on chat on the Telegram channel. There are a whole bunch of people, but yes, it may not be easy to identify which of these is right for your child. Sometimes a more evaluative kind of competition kind of thing at a younger age might actually backfire. So I have a question to the panel. This is a question from me, but it's also based on some parents who sent messages on Math Olympiad. I think they were asking, how do you prepare your child for a Math Olympiad? So my honest question is, are Math Olympiads a good idea for all gifted children? Is it possible to be gifted in math or have a lot of strong aptitude in math, but not do well at Math Olympiads? And if children choose to do Math Olympiads and enjoy these, what would be ways to go around preparing for these?
I think I will answer that first, because so first of all, this nomenclature Math Olympiad, I think we need to be clear what we're talking about, because there is this one international Math Olympiad, which is a very, very good quality international assessment. And if you are aware, the Homi Bhabha Center for Science Education in Mumbai is the agency in India that officially is the representative that both helps and coordinates India's participation in this. This is something in which a team goes from the country. But if you go through, and I could share the link if you want, but on the Homi Bhabha Center site, you have the process, and it's something that goes through schools. It's not a very good, it's not a great process, but they do this, identify a team like other countries do, and then a team goes there, and this team represents India, and that is the International Math Olympiad. Now, the term Olympiad is often used for many tests that exist in the environment, and as a parent, I would say just kind of scrutinize those tests. Many of those tests are actually not good quality tests, not really tests that are truly testing for understanding. So there may not be a need to kind of over test unless you know that it is of a certain quality and it is truly the whole problem that we are trying to escape from, I think more so here in India, is that the school system tends to be a little straitjacketed. This is the curriculum, this is the textbook, do this, get this mark, and don't think outside the box. So be careful, that's the way I would put it, be careful that the test is not following that same philosophy, because it may actually come in the way of the child's interest in mathematics. And if you do find tests that are doing the other thing, sure, go ahead. But just wanted to clarify what the International Math Olympiad was, and I'll just share the link that, where you can get more details about that.
So I might follow up on a different piece of your question there, Vishnu, is like, because Math Olympiads, first of all, they are kind of traditionally, or math competitions are a gateway to becoming successful, I guess you might say, in the mathematical world. But it's also true that it's nice to understand that they are not for everyone, okay? Not everyone has a competitive nature. Not everyone is as interested in speed. And one of my concerns, quite honestly, is, and this came up with one of the parent questions before, I think, students present their mathematical interests and abilities in different ways. And we're accustomed to thinking in terms of speed and computation and competition. And there are lots of very, very bright mathematicians out there who tend to be rather slow thinkers, quite frankly. And they're the deeper thinkers. And they're the ones who will take the time to get way into a problem. And I've seen this like over and over and over in my teaching. Sometimes the quieter, slower kids who kind of fly under the radar in your classrooms are some of the most brilliant kids, and we tend not to recognize them. And I think, as you're thinking, I think in India about how are we going to go through this process of identification, I don't know that anyone really knows the answer to that. but keeping an eye on this idea that there are a lot of people who don't fit our image of students who are brilliant in math, who probably are. I have seen, like, as I went through graduate school, I saw so many students who thought they loved math and didn't discover that they did not love math until graduate school as a math student, because they thought it was all about the computation. And there were other people that I've seen who have gone and left mathematics who I know would be brilliant mathematicians because they didn't fit the traditional idea of what a mathematician looks like. And they might not be the people who are interested in competitions. Some people might be familiar with Eugenia Cheng. She's written some interesting books like How to Bake Pi, as in PI, and other kind of fun mathematics books. And she's a category theorist, which is about the most abstract mathematics that you can imagine. And yet she dislikes competition. She tries to structure her classes in a way where students are kind of working together and collaborating things. So they're great for some kids. Competitions are exactly what students want, but we also want to be watching for those students who sort of don't fit into that traditional way of seeing things.
Thank you. I think,
thanks, Sridhar and Jerry. I think that was quite illuminating. Mick, do you want to add anything on that?
I think I agree with what they both said. I think scrutinizing these so-called Olympiads, especially a lot of these things are commercial operations in India. They're not really high quality. So it's really important to do that. I do agree, even though Jerry and I have a fundamental disagreement about the value of acceleration, I agree with a lot of what he has said tonight, especially this warning about adult-driven acceleration. And I also fully agree that there are people that do not enjoy these competitions. However, in my experience, Olympiads and competitions, if they're done well, like if you have a school with a mathematics team that has the right approach, it's not about really competition or winning or coming first. It's about the fun of the problem solving. And that's where I say artofproblemsolving.com has just an infinite pool of resources at every level where you can really work with kids and understand whether they enjoy this kind of approach to mathematics or not. And if they do enjoy this kind of approach, I would suggest that you follow up and try to get them connected to a math team or an organization or somebody who's training for an Olympiad, not so much so that they can win and be recognized, but so that they can be around other people and exchange ideas with other people who think like they do, and so that they can learn.
great. Thank you for the nuanced conversation that we've been having on gifted and interest in maths. And I guess I always used to think that someone who could solve maths problems faster ends up loving maths. But thanks for clarifying that, there are more dimensions to this. Vignesh, you've had your hand up for some time. Would you like to ask a question?
Yeah, thank you. Thanks for the opportunity. So I would like to ask what Jerry said. Actually, some people dislike competition, and moreover, some students, especially they are interested in one part of the mathematics. For example, my son is having quite a good interest in number theory, but at the same time, he's performing. He's not average, but he's doing, not comparatively not very good in geometry. But the evaluation system in Olympiad requires the equal intelligence in number theory or geometry or combinatorics. So this is whatever, if suppose if I am trying to enforce him about on geometry, learn geometry, he's not really keen on learning it, but his area of interest is number theory as well as combinatorics. So how to deal with this? So for most of the exams, if he has to clear, equal knowledge on every topic is required.
And thank you, Vignesh. Actually, what I'm going to do is, for the convenience of the panelists, I'm going to ask 3 or 4 questions together, and then pick the ones that resonate most with you, and we'll go through each of you. So after what Vignesh said, also, how do you know as a teacher to balance out children who are really gifted and children who need your support and who have learning gaps, right? So how do you trade off equity and excellence to be able to cater to all students? And what we find is that as grades increase, the gaps between the truly gifted and the children who need more support also expands, which makes the job of an educator really complex. So, how do you wrestle with this debate, and how do you do that? So that's one question. The second question is, we've talked so much about put your children in good school, that the school has a lot of influence on what your child would do. But how do you find out if the school is good? Because everything looks good from the outside, right? I mean, what are those leading indicators that you can look at in identifying a good school? So, and then the third question, before I open it up, is that it seems like there's our conversation today was strongly focused on identifying and nurturing gifted students, talented students. But can some of the same ideas be modified to help the students who need more support, students who are below average, to help them improve their subject matter understanding? So those are the 3 questions, and you get your pick to go.
Okay, well, I guess I'll jump in here. The the equity versus excellence thing is such a challenging question, and I feel like, and I'm not I'm not really familiar with where things stand in India at the moment, I guess, but the equity piece has become so much more visible recently, certainly in the US, and I'm guessing elsewhere. That quite honestly, it's giving me new perspectives on this whole idea of giftedness and how much we can be, there's always the necessity to meet the needs of an individual student. And yet we have to always be aware that in the process of doing this, we put people into categories, and we're absolutely leaving so many students behind. I wish I had some clean answers to this, but I think the best answer that I know of right now, apart from learning as you're beginning to work together in India on these questions, just keep these things in mind, to be aware of the fact that we know we're missing kids. Disadvantaged students clearly are vastly underrepresented in this. Okay, there are clearly extremely gifted kids out there who are not finding and we're not supporting. But the idea that it ties in with your third question, which is, do some of these ideas work for non-gifted students as well? And I would say yes, with 5 exclamation points on that. If you're talking about, not if you're talking about acceleration, not if you're talking about speed of instruction, but if you're talking about depth, if you're talking about creativity, if you're talking about conceptual understanding versus only rote learning, virtually the vast majority of the things that work well with gifted students work with others too. And it comes back again to low floor, high ceiling kinds of questions. It means asking all kids to problem solve and assuming that all students can problem solve. Even if they're not doing well on tests, even if they're not great at computation, teachers and all of us tend to have this idea that, well, they can't go to this next harder kind of problem until they've learned to multiply 2-digit numbers or something like that. And I do think that's a very big mistake. we need to assume that all kids can solve challenging problems, and we need to give them the opportunity to do that. And we don't want to wait until they've reached some, threshold of what we consider to be able to do simpler computations or something like that. Often they can learn the computation process through solving challenging problems. So just being aware and believing that all students can do these things and presenting them with the opportunities to do it. And not making them wait until they've gotten 90% on such tests before they start being given challenging problems, to me is at least a first step.
Okay, I'll also jump in and share some thoughts on these. So, the equity versus excellence problem is interesting in many dimensions. One of the interesting things that I just mentioned is that, internationally, when they have looked at countries, and for example, in India, we clearly talk of equity. If you look at the Sarva Shiksha Abhiyan, there are 3 goals, and equity is a very key goal. But what international studies show is very, very kind of contradictory to the way policymakers think about this. They basically find that the countries that have done best on equity have done the best on excellence. And you can put it the other way around also. The countries that have done best on excellence have done best on equity, which means that you do not look at these two as, and it's challenging, right? Because it appears that they are contradictory goals. Where do I spend my time on? But that is one perspective I wanted to share, that the answer probably is that these are not contradictory. You do better on one, you actually do better on the other. The other aspect of this is that, when we used to run these gifted programs and in Gen Y's program, one of the things that we kind of look at is that when I am giving, if the child is going through a 3-week program where they are learning something in mathematics, or it could be in a different topic of their interest, but somewhere when we look at why are we doing this, we are doing this because historically the data clearly shows that investing on gifted students does not only benefit the gifted students, it has significant social benefits. And we must understand that gifted students can come from anywhere, and that's where some of the equity point comes in. But if you invest on gifted students, they are probably going to help you solve some of the largest challenges that we need to find answers to. And the other side of this is that in the 3-week program, we spend 10% of our time telling these students that you have this gift. How are you going to use this gift? Is it just for, because you love maths, you do maths? Is it because you will solve some maths problems? Or is it because this is also a tool to solve some of the bigger problems that, are relevant? I mean, Andrew Ng has this quote where he says that the world is full of interesting problems. The world is also full of important problems. And I wish that bright people would pick up the important problems. So that's the other dimension of equity which kind of justifies these kind of giftedness programs. It's very obvious that when I invest in this, there is a benefit. And I think it also makes the life of the student richer, because I'm not just doing this because I'm passionate about it, but I'm doing this to solve a larger problem. We have this program called MindSpark, right? Now, I wanted to mention this for 2-3 reasons. One is we clearly see data that children who appear to be slow may actually be learning things at greater depth, something that Jerry mentioned. And so that and therefore the child who appears to be slow, if I can give him inputs that he needs, which may be kind of behind what the class is doing, he actually kind of understands this concept better and may actually in a year or two see, have that kind of excellence in mathematics or the other area. But the other reason why I want to mention this is that, this is where the opportunity where Pranav talked, and we talked about this equity point, that I have this whole range of children, some who are weak and who need support, and some who are strong and need enrichment. How can we do this? And it's the philosophy here where you say that, okay, the idea is to match this and to provide that kind of challenge through the system. In fact, one of the things that we have found in a few examples is that children who've been really fascinated with mathematics have actually helped create 1 or 2 modules in MindSpark that have then been used and other children have found challenging. So, want to put that also out there. And then there was a question about, how do I know the school is good? So, when we have these assessments, and again, this is not something that's necessarily happening today, but assessment data can show you not just where a school is performing, but it can show you how much value add a school is doing, because I have this data at the grade 3 level, a grade 4 level, and then I can say how children are doing at a grade 9 level. So a lot of this to me is about moving the conversation in a country, and I think people like us have to do it, where we are talking about real learning, identifying and developing this kind of talent, and not the narrow focus that is there today on marks. So I see that as part of the problem too.
Well, I fully agree with what Sridhar said about there shouldn't be a choice between equity and excellence. And to get back to the question of what is a good school and how do parents choose a good school, I think that what we've discovered tonight, and one of the things that we're learning, is that every child is different, and you have to find a school where they will understand your child. And nobody is more important in that process than a good teacher. And a good school is one that has excellent teachers and keeps those teachers. A well-managed classroom with an excellent teacher is one of the happiest places in the world. And it doesn't matter if the child is weak in mathematics or strong in mathematics or gifted or needs support or needs enrichment. All of the children will thrive if it is a classroom with an excellent teacher who has set up a safe and fun and joyful and challenging learning environment for every kid in that class. So I would suggest that for parents, the best way to find out if it's a good school is to ask other parents of that school, because parents want what's best for their children. And when the children come home happy and engaged and learning and bubbling with laughter and joy and wanting to do their homework because they have excellent teachers, that comes through and the parents know it. So when you're trying to choose a good school, I would say ask the parents and perhaps even the children of that school, and you will get the best answers. The last thing, and I'm really glad Sridhar brought this up, is we haven't really talked enough about computers and the role of computers in mathematics education in the 21st century. And now a lot of really interesting research is coming out that shows that computers are better at teaching low-level language skills than human beings. And especially out of Europe, which is such a multilingual place, we're seeing that computers are excellent at teaching things like how to conjugate verbs and how to memorize vocabulary, etc. And when I look at MindSpark and Khan Academy, and I see how quickly the kids are learning, and I see how much they love it, and I see how much they enjoy the gamification and moving up the levels and all of that, I really think there does need to be more of this in schools. And we do need to encourage parents to use some of these resources. And many of these resources, like Khan Academy, are completely free. And unlike those Olympiads, those suspect Olympiads that has low quality questions, Khan Academy questions are excellent. So I think that's also an answer to some of our equity issues when you have excellent free resources that are available.
Thank you, Jerry, Sridhar, and Meg. You've been at this for an hour and 20 minutes now. So I'm gonna change this up just a little bit for this last question. So we have a school owner, the founder of Head Start Learning Center, Sudha Mahesh, and her question was, how can they do good mathematic projects in middle school? And I'm going to actually invite Soumya from GenWise to be able to answer this question based on the work that she has done with other schools. Yeah. Soumya, if you could please answer Sudha's question.
Yeah, thanks, Pranav. My connection is bad, so I've actually dropped out a couple of times. So I won't dare turn my video on,
Okay.
but I hope you can hear me.
Yes, we can hear you.
Okay, yeah. So yes, so we are working with a Bangalore-based school on several things, and one of the things is this project-based learning for the middle school students, and this has been over the past year, which means it's been all online. So it's been extremely interesting, and it's been quite a challenge for the teachers. So what we have found, I can certainly share some specific resources with you, so that's not an issue. I can mail something to you that you will find useful and interesting. That's not an issue. But the general thing, what we have found is the PBLs work well at the middle school under the following conditions, which are all not easy to sort of maintain in a classroom, more so if it's online, and more so if you have a full class of 25 to 35 students. But still, it's good to have that up there, which is that the first thing is to push the boundaries of the, in quotes, syllabus, and to sort of get out of what might be called the tyranny of completing the portion. That was one thing. The other thing is also to sort of include multiple topics in a PBL, which also seems to be sort of not so easy to do if you're running a regular sort of a conveyor belt system to get going with the classroom and that kind of thing. And also for this on the pandemic situation, having these children work together seem to be a big hit, because otherwise they're just doing their own thing, and although they don't want to turn on their videos in middle school and they don't want to see each other, they do want to work with each other, and it's they really come alive when there's a group working to solve and working to present both. They seem to thoroughly enjoy that. The other thing which we found was very necessary when we were discussing this PBL with teachers was introducing advanced topics before they formally come into the syllabus, to sort of introduce them peripherally on the side without using the word fractals, without using the word slope. And children love it. And teachers sometimes feel a bit nervous about it. But the children really loved it, and this was another thing that was gratifying. Another specific thing that helped was to sort of discuss with the teachers and to sort of document specifically also what the questions and the hints were that were to be given by the teachers, as opposed to giving the answers or giving the solutions. I mean, Jerry is a master at this, and I've just watched some of his classes, and he leaves questions completely open, and that's quite that's quite an advanced art, I think. But to do it within the constraints of a classroom for a teacher, so we found that throwing all these elements into the PBL, the students seem to have been extremely happy. They responded saying they really enjoyed the PBL, and they learned quite a bit from it, and the teachers were happy too. The specifics I can certainly mail you, Sudha, if that is okay. Yeah. Thank you.
Vishnu, before I close, is there anything you would like to share?
No, not really. I think it was great, and I know there is a lot more Mick, Jerry, and Sridhar can enlighten us on. Maybe after a few months we'll be back. A lot of parents have some more questions. We've not managed to address everything, but maybe we will send them to you on email and discuss on email. Yeah, sure. So thank you everyone for being part of this, and
Thank you.
okay.
Thanks a lot.
Bye.
Yeah. Bye.
Okay. They have managed this by putting multiple things together, right? By school is doing something, they get someone in. Even in Micks' own school, there is somebody else who runs a recreational math thing. So Mick, maybe you want to talk about it, but my own thing is that, it's hard for a school to always address the needs of children who are really off the charts. Yeah.
Got it.
I think you've put your finger on it, Vishnu, and you're really looking for a school that will work with the parents, right? And, so it's not just creativity and mathematics. It's also, these days we're seeing it more and more with athletes, right? So we get a kid who's extremely talented and has a goal to become an Olympic swimmer or an Olympic squash player. And the parents come and they ask us, are you willing to work with us? And this kid can only come to school 2 days or 3 days out of the week because she's got training and she's on a pre-Olympic path and all this kind of stuff. So it's really about whether the school understands the child, the family, and the way everything is being differentiated these days. And if the child has particular talents, will the school work with the parents and the family to allow the family to pursue that child's talents both inside and outside the school? So chess players is another example. We're here in Chennai and we've got quite a few kids who are really, really competitive in chess. And they need hours per day to do their training, whether it's chess or swimming or squash or whatever it is. So the real question is, can you find a school that will appreciate your child's talents and will work with you and work with the family?
Yes, I think that's a great point. So if you can find a school which can address those specific interests, great. Otherwise, go for flexibility. I just want to share a quick anecdote. The child called Saad Nasser, he's now 18 or 19, but when he was in grade 2 in Clarence School in Bangalore, he was like super gifted, right? And at the age of 14, he became the chief technology officer of a automated self-driving, vehicle company. So what happened is the school said, listen, you can just come and take the exams. You can, be at home, do whatever you want. There was a mentor at Intel Corporation first who helped him. Then there was a Dr. V. Vinay, who was a computer scientist who helped him. And the kid studied on his own, got some mentoring. So, it depends. It depends on how precociously gifted the child is. That's a huge sort of continuum out there. So I'm going to stop here, I think. Yeah, sorry, Mick, you were saying so. Yeah.
Okay, thanks. We're a couple of quick announcements. So just in terms of identification of giftedness through assessments, student scholastic assessments. So we at EI run the EI Super Test as the first level, and then the Asset Talent Search to identify the gifted students. And then the students who qualify are eligible for gifted programs. And GenWise conducts many of them. So we have open registrations for the Winter 2021 residential program. It's at the Padukone Dravid Sports Center for Sports Excellence in Bangalore. It will be between December 18th and 30th. That's essentially 2 weeks, but we also have a 1-week option. There are 4 exciting courses: forensic science, physics, economics, and neuroscience. And we have some advanced courses for students who qualify at the gold, silver, and bronze levels of the EI Asset Talent Search. These are for students in grades 8 to 10th. And there's an early bird offer as well. So more details are on genwise.in. The website link is pasted in the chat window. But I, sincerely want to thank Jerry, Mick, and Sridhar for getting into very specific details on giftedness, for giving very actionable insights, and for unpeeling the multiple layers of mystery around giftedness. So thank you for telling us how to identify it, how to nurture it, the role of a parent, a teacher, a school. So really, really informative session from the 3 of you. I also want to thank the team at GenWise and EI for putting together this session tonight. So please continue to follow us on the Telegram channel here for everything on giftedness as a topic. We have lots of resources that we plan to share through that. And yeah, follow the Gifted India Network. Thank you, everyone. Thank you for joining us, staying with us for an hour and a half, and we'll close now.